There are several considerations involved in management of spider mites on outdoor plants, which will be the focus of this little period of time. I want to go through how you might check plants to detect incipient infestations, how to monitor high-risk plants. There's quite a few interactions of environmental conditions with spider mite in spider mite outbreaks, and wish to discuss those, drought stress and humidity. And then when we get to the issue of pesticides, there is special concerns with using pesticides appropriately on spider mite susceptible plants, because there's relatively few products that work well on spider mites, and there's quite a few products that don't control them but can actually make problems worse. But when we're discussing monitoring, there's a couple things you could consider. And the importance of monitoring is to catch spider mite populations when they're low levels, before they have gotten to a point where it's going to be very difficult to bring them around. And on the right, I have two pictures that show spider mite injury. And spider mite injury is something that anyone who works in plant care should try to get a sense of what it looks like. It just little flecking. So for instance, in that nasturtium leaf at the top, just little white flecking. That should be something that your eye should be trained to detect. In the picture on the lower part of the page here, there are needles that have various levels of spider mite injury. The one at the bottom with just a little bit of flecking would be one that you probably want to be able to detect before it had progressed to causing serious damage, as indicated on the, say, the second needle from the top there. So just getting an idea of what plants look like when they've got mites is something that you should try to work on, and it's something you'll just get with practice. There are also ways you can actively monitor for spider mites. Indicated in the picture on the left is a way to actively sample for spider mites, in this case on a blue spruce. And basically the typical method would be to beat or shake a branch or leaves of a plant that you wish to monitor over a sheet of paper or a tray, and then watch to see if there's any spider mites that have been dislodged. I mean, wait 15-20 seconds, and the dust that starts to move is spider mites. So it's fairly straightforward to do those kinds of sampling. They're small, but they are visible. And furthermore, if with a little bit of magnification, if you have a suspect leaf, you can look, and they leave such good signs. They leave the cast skins, they leave the old eggshells, and you may be able to see the mites themselves. So it's a fairly simple kind of problem to diagnose. The difficulty is in detecting it and looking at plants at an early stage in an infestation. Now, in landscape settings, there are quite a lot of interesting interactions between drought, dry air, and spider mites. And we can have changes in the physiology of plants that are under stress that can cause them to perhaps be more suitable for spider mites as a food source, or they will change in their tolerance to the mite injury that is occurring. We can see alternation of leaf surface temperatures being related to drought and drying. There are interactions with relative humidity as well that can involve several different species, including the natural enemies. And physical effects of irrigation or rainfall also can affect spider mites. Anyway, let's get into some of these. So if we have drought, insufficient water, there's a couple of things. I mean, one of the more obvious things is if you have a plant that's under drought stress, then it is not actively growing, and then it will be less tolerant of any injury that does occur, be it from spider mites or anything else. So that's pretty straightforward, but some of the other things are a little more subtle and perhaps a little more interesting. So, for example, there are a couple things that can happen on a plant that's under drought stress that can favor spider mites. One is by changing the physiology of the plant. Drought stress plants can become nutritionally more suitable for spider mites. There may be changes in the cell chemistry that make them more nutritious, so that spider mites might be able to reproduce more quickly on a drought stress plant. may not happen with all spider mites on all plants, but there are several cases where this has been demonstrated. Another interaction, if you have drought stress, is that leaf surface temperatures rise. The stomates aren't opening as often, and you may get a change in the temperatures on the surface of the leaf of a couple of 3 degrees. Now, this may not sound like a lot, but it can have a huge effect in terms of the relative rate at which spider mites are going to reproduce, since they're going to reproduce faster at these warmer temperatures. So those are 2 ways that a plant, if it's under drought stress, could make them more suitable to be infested and damaged by spider mites. The other issue is dry air, just being having low humidity. And there are a couple of things that are related to dry air. One would be that the rate at which spider mites can feed can be affected by humidity. They're taking in lots of fluids as they're breaking cells and taking in the release cell contents. The fluids are a lot of extra water that they have to eventually get rid of, which they get rid of through evaporation of this waste fluid. If it's more humid, evaporation, of course, occurs slower than if it is drier, more arid. Also, dry air is often quite stressful to some of the spider mite predators, and there are a lot of kinds of predators that can affect spider mites if conditions are favorable. The primary things that do feed on spider mites, though, are little animals. So in this slide right here, we have 3 common predators that would feed on spider mites. In the top is what's called the minute pirate bug, and it is a kind of true bug, and in this picture it's feeding on a thrips. It's a very tiny bug, 1/10 of an inch or so. In the picture on the lower left, we have a predatory mite eating a spider mite. So these are mites that are about the same size as a spider mite. And in the lower right is a kind of thrips, one of these banded wing thrips that are actually predators. They feed on mites. Anyway, all of these are small. And being small, you have a large surface area to your mass, so it is difficult to keep adequate moisture, and when it gets dry, you have a lot of surface from which you can lose moisture below a critical level, then you're in trouble. So often these cannot do very well in a very arid climate. So as example, there are several kinds of predatory mites that are available for purchase. You can buy these, and they're most commonly used in indoor greenhouse operations. So, for instance, one of the most common one, and one that in several kinds of settings has done excellent work, is a predatory mite called Gallandromus occidentalis. When you look at what kind of conditions are optimal for it to do well, you can see it 80 to 100 degrees Fahrenheit, so it likes it fairly warm, but it also needs greater than 50% relative humidity, and that can be the problem. I mean, and there's not a lot of tolerance among any of these predatory mites for very arid conditions. So the one that is sold and promoted as perhaps being the predator mite that is most tolerant of arid climate, arid conditions, is this Mesoceolus longipes, and the manufacturers point out that this can only tolerate the very low humidity of 40% when the temperature is 70 degrees Fahrenheit, and you'd need increasing humidity as temperature rises. Now, in arid climates, this can be difficult to achieve. But small changes in the microclimate can have huge effects on spider mites and on the predators that are affecting them. As an example, this is the morning glories that are growing right outside my front door. They grow every year from seed. The morning glories here are in the back, growing right next to the house, up a little drain pipe, and the ones in the front are growing up a little trellis. This has got a small porch in the front. Every year, these plants come back, and every year, the morning glories that are growing next to the wall, next to the house, are covered with spider mites. And every year, the morning glories that are growing no more than 8 feet away, but a little further out on that trellis, have essentially no spider mites. And this is because of differences in the conditions that are occurring very close. The ones next to the house are in a warmer site. They're getting reflected heat off the building. It's also a little bit drier next to at the base of the building than it is a little bit further out. There's a little more moisture. But this illustrates how sometimes if you could make some little changes maybe in how you sited a plant, that it could become much less or more susceptible. So you have roses that you have a chronic problem with spider mites on, and maybe you move them away from the wall or away from some other area that's getting some reflected heat. Maybe put some mulch around them, increase the humidity that way, and you may easily find that spider mites are no longer an issue because of some small changes you made in modifying the environment. And another example of this is this honey locust spider mite that I mentioned is a problem when you grow honey locust as a street tree or in a parking lot, but you almost never would see an outbreak of spider mites on a honey locust if you grew it in your front yard or in a park where there's a little more humidity. Just as a little another side example, well, I found this to be pretty interesting several years ago related to honey locust spider mite when I was visiting Chicago several years ago. The city of Chicago has a very large number of honey locust trees. It's a very widely planted tree, and in general they look pretty good. But in one place they did not. And this was Millennium Park, a major park in downtown Chicago. And what we see here are some honey locust trees, and in the back we have a bandstand that was produced. There was also, right next to this little bridge. There was the BP bridge we were walking across, and all around this one site there was spider mite outbreak that was way more visible than in any other place that I observed in the city. I think the reason for this, why there were spider mites in these sites, is there's some features in these sites that probably are contributing, and specifically architectural features. So that bandstand in the background and that BP bridge, if you can remember back, both of those were made of very reflective stainless steels, reflecting quite a lot of light. And these are both structures that happen to be produced by a very famous architect, a guy named Frank Gehry, who happened to design this building that my brother-in-law works in, which when it was built, it reflected so much heat off it, it was melting plastic garbage cans across the street. So this architect likes to use very nice shiny surfaces in his work, which can be very striking, but at the same time does contribute to changes in microclimate that if you have mite susceptible plants nearby, they will contribute to mite problems. So I call this Gehry building syndrome. So any kind of site where you have again a lot of reflected heat could have the same kind of effect. So rainfall and moisture and irrigation can also affect spider mites. We don't have a lot of rainfall, but we certainly irrigate quite a bit, and there can be several effects from the rainfall or overhead irrigation. They can be direct. They can help reduce the spider mite numbers by knocking them off plants. They can also retard their development. So, for instance, in one study done several years ago, monitoring spruce spider mites, if there's a daily rainfall event, there was a 93% reduction in spruce spider mites, and 2/3 reduction if there was a rainfall event every other day. And we can simulate rainfall, of course, by irrigation and hosing plants. And this is something that in small settings might be useful. Certain kinds of shrubs, perhaps, that you have an issue with. And, of course, indoors, if you have indoor plants, hosing them off regularly when you detect early stages of a spider mite outbreak can be very useful if done diligently to keep the numbers down, so that you can get by without having to perhaps use a miticide. Which brings up what we have to control spider mites. There are some mite control products on the market. Very few of these are available over the counter, but for commercial applicators, there's quite a few options. Uh, these range in their selectivity of action. Some of the mite control products are extremely selective in their effects. They only affect spider mites, even certain kinds of mites. Maybe some of them work on rust mites and some of them work on spider mites, but they don't work on insects. They are, again, very, very specific and very conservative of the natural enemies as a result. Then others have different degrees of how disruptive they might be to natural enemies, with some of them being quite destructive. But spider mites are not insects, and the kinds of products that work on spider mites are often not insecticides. In fact, many insecticides can aggravate problems. They can make it worse. So this is a silly little cartoon of a spider mite, and she is showering in the common garden insecticide 7, or carbaryl, which is an insecticide that is fairly notorious for being able to contribute to outbreaks of spider mites. It is an insecticide that works on insects. It can be very effective for certain insects, but does not make claims, never did, for spider mites. And on mite-susceptible plants can aggravate problems with spider mites because it is not affecting the mite itself, but it is affecting the natural enemies. So most insecticides will kill predators of the spider mites, and if they're ineffective against the mite itself, then the spider mite populations can increase. They can flare. They can be aggravated. So again, we do have some products that are out there. The most selective of all the kinds of mite control products would be largely indicated in this list right here in the bold. Again, most of these are quite specific. The one that is more broadly available and perhaps a little less specific, we've talked about it for controlling several kinds of insects, are the horticultural oils. And frankly, if we're talking about spider mite control in a yard and garden, and a homeowner wishes to do it themselves, these horticultural oils are pretty much all we have as an option, because the more effective mite control products are not marketed to over-the-counter use. Then there are other kinds of mite control products that have variation in terms of how disruptive they are to natural enemies. The spiromesifen and the abamectin are highly effective mite control products, but they also will affect some kinds of other insects as well. And then pyrethroids and some of the other insecticides. We have malathion, carbaryl 7, I mentioned. These are perhaps these tend to be quite destructive to natural enemies. They're non-selective in their effects. So use of some of these broad spectrum types of materials will result in a increased problem with spider mites in many situations. Just want to have one other note in terms of a spider mite issue with pesticides, and that's with this imidacloprid. This systemic insecticide I've been mentioning that could be used to control aphids or some of the scale insects on trees and shrubs. An observation was made in the mid-1990s, shortly after these products started to be used on trees, that although they were working very well for things like European elm scale or aphids, spider mites seemed to become more important, more common on some of these trees, trees and shrubs. And in a little follow-up, some trials were done. Again, this goes way back to mid-1990s, and treating, in this case, marigolds with the imidacloprid. And when this was done, as it turned out, the spider mites would be far more injurious to plants that had been treated with imidacloprid than the untreated check. Now, originally, the thought was that these soil-applied systemic insecticides were working primarily by adversely affecting natural enemies, and I'm sure that is part of the answer. The risk here, or imidacloprid, even though it's put into the soil and taken up by the roots, some of these insects that feed on mites will occasionally take a little drink from the plant and could be exposed that way. However, as it turns out, there's something even more interesting that recently came out on this, and that was that some neonicotinoids apparently can have effects on the hormone systems of the plants. They specifically can suppress the production of the jasmonic acid pathway, which is the natural pathway that plants use to resist attacks by insects. So essentially, these insecticides, although they can work very effective for controlling certain insects, they are suppressing the plant's systemic responses to these kinds of invading pests, and therefore they can do better. So part of the reason that spider mites appear to be more common on these plants that are treated with some of these neonicotinoids is that the plant defenses are suppressed as a result of the insecticide. Anyway, the spider mite management, again, does involve a couple of key principles. Do always check plants, particularly if they're an at-risk plant, a high-risk plant. Check them to make sure they do not develop populations that are going to cause problems in turning around. The drought stress and the humidity situation, sighting of plants can be huge in how they're cared for in terms of susceptibility to spider mites and the incidence of spider mite outbreaks. And again, particular care needs to be made when selecting a pesticide for spider mites, because these are very different animals. The kinds of things that work on them are often very different from an insect, and if we use them inappropriately, we can sometimes make the problem worse for us. So I think that rounds out the discussion for spider mites. So next week we'll be hitting turf grass.